Alright, so let's start with substitution. Now we've just talked about graphing two equations on the same graph, on the same coordinate plane. Now we're going to talk about what's called substitution. And the way this works is you're going to be given two different equations. So you might have one that says x equals 4y and another one that says 4x minus y equals 75. What we're going to do is, because one of our equations just has an x on one side, so one of the variables is all by itself, we're going to take this 4y and replace my x with a 4y every time. So, for example, I'm going to do 4 times 4y. So I'm taking the x out and replacing it with the 4y. And then I'm going to say minus y equals 75. Okay. Going to multiply, so I got 16y minus y equals 75. Now remember, there's always a 1 in front of this y. Okay, so that means that 16y minus 1y. So now I have 15y equals 75. From there, we're going to then divide each side by 15 to get y by itself. So you have y equals 5. Okay. Oh, that was a bad circle. Alright, but the thing is, we just solved half this problem. If you remember, when we graphed, we had an x-coordinate and a y-coordinate because we had a point, an ordered pair. So what we have to do is we have to take this 5 and plug it in and figure out what my x would be. You can plug it into either one, but I always go for the one that says x equals or y equals because my life is going to be a lot easier and I'm going to have less work to do. So in this case, we're going to take my x equals, and I'm going to replace the y with a 5. So I'm going to have x equals 4 times 5. Multiply those two numbers together, and I get 20. So my ordered pair is going to be 20, 5. So that's my answer. So no matter what, going back over here and looking at our two original equations, you guys are going to have an answer that will work in both. So if I plug in my x, which is 20, and say 4 times 5, that is going to give me 20 on each side. If you go in here and you replace your 4 with a 20, you have 80. Minus 5 is 75. It checks out. So let's do another one. This one has an extra step with it. Alright, here we have two equations that are in standard form. So x and y are on the same side. So what we have to do is, I'm going to take this first one and solve for y. So let's rewrite it. Got that. I'm going to subtract 4x from each side. You're probably going to ask why I'm choosing to subtract 4x from each side. It's because y is all by itself. There's no number in front of it. There's no coefficient. So for me, it's going to be a lot easier if I leave y on this side. So I'll have y equals. And just like with the first one, I'm going to be able to replace my y with a specific expression. So back over here, so I've got y equals negative 4x plus 12. Right? So now, where I circled that y on the second equation, I'm going to plug in my 4x plus 12. So you're going to have negative 2x minus 3 times negative 4x plus 12 equals 14. Please be careful about which, if it's addition or subtraction in front of that 3 if you have to distribute. Because there's a subtraction symbol, that means when I multiply, you're going negative times a negative and then a negative times a positive. So be careful and watch your signs. Okay, so now you've got 2x plus 12x minus 36 equals 14. Combining like terms. Okay, so I'm going to get 10x minus 36 equals 14. Okay, I'm going to add 36 to each side because I'm still just solving for x. I've got 10x equals, so 14 and 36, that's going to be 50. Divide each side by 10, and I'm running out of space, hold on. I've got x equals 5. So part of my ordered pair is going to be 5. We're still not done yet. We have to go back up And what I'm going to do is I'm going to use this equation that we solved for y in to find my y. So I'm going to go y equals -4 times 5 plus 12. Then I'm going to get -20, because -4 times 5 is -20, plus 12. I'm going to add these two together and get -8. So my ordered pair in this case is going to be 5, -8. Right? And that is my second example for this lesson. We'll talk more in class.